Okay, now we're going to talk about how to add and subtract rational expressions. Okay, your number one goal when you're trying to add and subtract rationals is to make your denominators match. So if I'm looking at this first problem here, I'm going to see this denominator has an x plus 4 and this one has an x minus 1. So what I need to do to make them match is to multiply this x plus 4 fraction by what it's missing. It's missing the x minus 1. So I'm going to multiply this guy by x minus 1 over x minus 1. And I'm going to do the same thing on this side, except this time I'm missing x plus 4 to make them match. So I'm going to multiply by x plus 4 over x plus 4. Then I'm going to rewrite what I got. 2x minus 5 times x minus 1 minus, bring this negative sign down, minus 3x plus 1 over, or say x plus 1 times x plus 4, and it's going to share the same denominator now of x plus 4 and x minus 1. Looks like I'm going to have to move this stuff down. From here, you're going to distribute both of these terms. 2x times x is 2x squared. 2x times negative 1 is negative 2x. Negative 5 times x is negative 5x. And negative 5 times negative 1 is positive 5. I'm bringing down that minus sign. And when I distribute this, I get 3x times x. That's 3x squared. 3x times 4 is 12x. 1 times x is x. And 1 times 4 is 4. Okay, now, very important, especially when you have subtraction right here. You must include parentheses around this right here, because this minus sign is telling you that you're subtracting everything behind it, all of this. So if I don't include these parentheses, then I wouldn't know that I would have to distribute this minus sign later. So very, very important, include these parentheses, don't forget them. From here, I'm going to combine like terms first, and then I'll distribute that negative sign. That's going to leave me with 2x squared minus 7x plus 5 minus 3x squared plus 13x plus 4. Now I'm going to distribute that negative sign. And I'm going to get negative 3x squared minus 13x minus 4. Basically, you're going to change all your signs. And now that I've distributed, I don't need my parentheses anymore, because if you'll remember, the point of parentheses is to tell you to multiply or distribute. Once you're done, you don't need them anymore. Still need to move these down. Awesome. Okay, last but not least, we're going to do combine like terms one more time. So I'm going to combine my x squared terms, and I'm going to get negative x squared I'm going to combine my x terms, and I'll get negative 20x. And I will combine my number terms and get plus 1. So your final answer is negative x squared minus 20x plus 1. Okay, I'm actually going to skip this problem here because it's the exact same process. The only difference is there's a plus sign here and a couple different numbers. And I will do these problems instead because I think they're a little bit more challenging, so they're worth talking about. So the first thing I'm going to do is factor everything I can. So I'm going to look at this and I see it has an x squared. That's a good clue that it might be able to be factored. And sure enough, if I think what multiplies to 6 that adds to 5, I can factor it with x plus 3 and x plus 2. Likewise, I'm also able to factor this guy. He is a difference of squares, so I can use my difference of squares formula, and I'll get my factors to be x minus 2 and x plus 2. There is nothing to factor on this side, so we don't have to worry about that. Okay, from here, you might notice that you have the exact same thing on the top and bottom of your fraction. So what you're going to do is cancel those two things. Once you cancel those two things, you'll notice that now your denominators match and you don't need to multiply by anything because they're already the same. So what you can do is immediately jump to the next step. X plus 3 plus 2 over the same denominator, x minus 2. From there, you're going to see that there's nothing out in front right here to distribute, so you don't need these parentheses. And then you'll combine your like terms. 3 plus 2 is 5, and so your final answer is x plus 5 over x minus 2. I'm going to start the next problem the exact same way. I'm going to start by looking at here, and your first instinct might think that this is a difference of squares, but then you'll realize that 5 is not a perfect square, so actually this can't be factored at all. But what you can factor is this guy down here. We just factored it up here, actually. So we already know our factors are x plus 3 and x plus 2. And you'll notice that when you factor it, you get x plus 2, which is already included in the denominator in the other fraction. So what you're going to do is you're just going to multiply this fraction by what it's missing. It already has x plus 2, so I'm going to multiply it by x plus 3 because my goal is to make my denominators match. From here, I'm going to rewrite it. And I'm going to look here at my parentheses. There's nothing in front that I can distribute that would actually change x or 3. There is a positive 1, but when you multiply by positive 1, it doesn't change anything. So I actually don't need these parentheses, and I can erase them. Which means now all I have to do is combine like terms. X squared doesn't have a like term, so we're just going to bring it down. X also does not have a like term, so we're just going to bring it down. But 5 and 3 are like terms, so when I combine that, I get negative 2 over x plus 3 and x plus 2. Last but not least, I'm going to move this up. Oops. Last but not least, you're going to want to see if you can factor your numerator again. And sure enough, when you think, what can I multiply to get negative 2 that adds to positive 1, you're going to find out that it can be factored. So you're going to get x plus 2 and x minus 1 as the factors of that expression, and it's going to retain its denominator of x plus 3 and x plus 2. And what do you notice? You notice that x plus 2 matches on the top and bottom, so they can cancel, which leaves you as your answer x minus 1 over x plus 3. And that's your final answer.